Hello, everyone, and very good evening. Welcome to this session. This is a revising session for work, energy, and power. So we at Arihant Academy, we are using this session for a quick revision during your exam time, and this advantage would be it will be staying with you throughout the year. Now, today we are going to revise a chapter which is work, energy, and power. My name is Miten Shah, and I am the physics faculty at ICSE Arihant Academy. So, without any further delay, let's get started with today's session. If you are watching it right now, please don't forget to hit the subscribe icon so that you can watch these amazing videos which are coming up for each and every chapter and each and every subject by all the amazing faculty here. So, let's get started with today's session on work, energy, and power. So, to begin with, the chapter is divided into three parts. The first one is the work part. So, the major chunk of the chapter is dedicated to the numericals. So, if you understand the theory part, the numericals would be pretty easy for you. And in the boards, generally this chapter is asked from 6 to 9, 10 marks. So, that's the on an average weightage of this chapter, but ICSE doesn't work on fixed weight pattern, but these are some of the weightage that we have seen in the past uh, times. Okay, so the first part of the chapter is work. Now, work can be defined as when you apply force and the body moves from one point to another. We say the work is said to be done in physics. Now, force and displacement, these are two major factors required for any work to be done. So, there goes the formula for it. Work done is force into displacement of the body. So, if you apply force and the body is displaced, then the work is said to be done. Now, it's not that easy sometimes if the force and displacement are not in the same direction, things become a little bit complicated. So, in that case, force into displacement is accompanied by cos theta. So, what is cos theta? यहाँ पे force का direction and displacement के direction के बीच का angle is the theta over here. So, if they are in the same direction, we don't have to consider cos theta. और अगर वो अलग अलग डायरेक्शन में जा रहे हैं या सम एंगल्स क्रिएट कर रहे हैं, then we need to consider the term cos theta. So that's the formula for work. Now, over here, F stands for the force and S is for displacement, and theta is the angle between force and displacement. So the units of work is measured in SI unit is joule and CGS unit is erg for the work. So as you can see in the animation here, if a body is being pushed by some force over here, that is 12 Newton, and if the body is moving from one point to another, the displacement here is 5 meters. So both are present, and therefore work is said to be done. Now let's have a look at some special cases जहाँ पे things are not just force into displacement. So let's have a look at the body over here. Imagine you apply a force in upward direction, but the body ultimately moves to the right. In this case, what is the angle between the force and displacement? 90 degree. Now, can I say 90 degree, yani this will be cos 90, and the value for cos 90 in trigonometry is found out to be 0. So now if you calculate work, what will happen? For work is force into displacement into cos theta, which is force into displacement into 0. The answer would be 0. In such cases, we say 0 work is done over here. Okay, so when do we say 0 work? When the direction of force and displacement are perpendicular to each other. So second case scenario, so 0 work done. Body, the force acting is, let's say, to the right, and the body also gets displaced in the same direction, which is rightwards. Now over here, what is the angle between the two balls? So first one, angle here is 0 degree, and the value for cos 0, I hope you guys must be knowing this, which is 1. So now let's calculate again work done. So work done will be Fs cos theta, Fs into 1, which is equal to Fs. So if we substitute, अगर हम यहाँ पे force and displacement की value substitute करते हैं, then answer would be a positive thing, and therefore we call it positive work. Okay, so zero work, positive work. Now let's have a look at the third case scenario. Body over here is being applied by a force on the left direction, and imagine the body moves rightward. Such cases happen. So in this case, the angle between force and displacement is whole 180 degree. So now if we have to calculate cos theta, it becomes cos 180, जिसकी value है -1. So if we go finding out work is force into displacement into cos theta, which is F into S into -1 and ultimately minus Fs. So इस फॉर्मूला में आप कोई भी फोर्स या डिस्प्लेसमेंट सब्स्टिट्यूट करोगे, अल्टीमेटली आंसर वुड बी अ नेगेटिव. So therefore we call it negative work done. So these are three special cases that we need to remember, and depending on what the question demands, apply one of those. Okay, so that is more about work. Now a question is asked generally, like what are the cases when work done is 0? So this is something, an example for zero work done. Have a look here. If we say that the orange line over here represents your force, the centripetal force. The force is acting towards the center. But how is the body moving at every point? They are moving tangentially, yani in the direction of the green arrow. So force and displacement are perpendicular to each other. Can I say, just like the previous slide, it is zero work done. Now, so can I conclude here that any body which is in circular motion, the work done is said to be zero, right? I hope you agree to this. The second condition where the work done is zero, that is, if you apply a force and the body does not move at all, yani no displacement, in that case also the work done is said to be zero. So these are two cases when work done becomes zero. Moving to the second part of the chapter, which is power. So when do we say a person is powerful? When a work to be done by a normal person is done more quickly or in a faster rate than a normal person, we say the other guy is more powerful. So work power is nothing but the rate at which work is done. यानी किस स्पीड से आपका काम हो रहा है. If the speed or rate is faster, we say the body is more powerful. If the rate yani speed is slower, taking longer time, we say the power is less. So power is the rate at which work is done. So basically work and time ka relationship is by power. So power is equals to work upon time over here. Now, in order to simplify this, work done can also be force into displacement. So, a modified version of the same formula is F into S upon T. Displacement upon time, if you observe here, can I say displacement upon time is velocity? So, another variation of the same formula is F into V, which is very important variation. काफी sums ऐसे हैं जो इसी formula से solve होते हैं. So, these are three variations for power. All right, आगे बढ़ते हैं to unit. So unit of power is watt, W-A-T-D, in the name of James Press. Sorry, my bad. In name of Sir James Watt. Then we have smaller units which are milliwatt, microwatt, and bigger units like kilowatt, megawatt, and gigawatt. Another unit of power which is pretty famous is horsepower. Sometimes it's asked as an MCQ that 1 horsepower is how many watt. So please remember this value, 746 watt is 1 horsepower. So that's introduction to power. And third part, which is energy. So work, power, and energy. So energy over here can be defined as the capacity of a body to do work. कोई भी body कितना काम कर सकता है, that depends on how much energy does that body contain. So basically energy is nothing but capacity of a body to do some work. Now, since energy जितनी होगी उतना ही काम कर सकते हो, so they both are equivalent of each other. So formula में भी इतने equivalent है कि energy is always equal to work done, जिसका formula है force into displacement. So please remember this relationship. Now, unit of energy again goes the same, which is joule and erg. So same units for energy. 1 joule is 10 raised to 7 erg. That's the relation between SI unit and CGS unit. 1 watt hour. Sometimes they ask you to convert watt hour into joule. So simply watt hour to joule, what we are converting here is hour to seconds. If we convert hour to seconds, we multiply by 60 into 60, which gives us 3600. And watt second becomes joule over here. And 1 kilowatt hour, simply we have to multiply by 10 raised to 3 for the kilo part in this unit. Now, speaking with type of energy. So we have experienced around us in your day-to-day life that there are so many different types of energy: mechanical, sound, chemical, electrical, light, heat, nuclear. So these are some of the major types of energy. In this chapter, we are focusing on the very first type, which is the mechanical energy. Now, mechanical energy exists in two different forms. Which are they? So the first one is potential energy. So what is potential energy exactly? Potential, the word potential means ability to do something. So when a body has an ability to do something but still hasn't done that thing yet, अब तक वो काम हुआ नहीं है. So for example, if somebody says you have a lot of potential to do a great things, यानी अब तक आपने वो काम किया नहीं है, तो आप में वो potential है. So same thing over here, if a body has energy to do something but it still hasn't done it, that is potential energy. So energy of a body due to its position or its state. For example, if a water is accumulated at the top of a dam, तो उसमें potential है to flow down या fall down. So उस dam में उस पानी की position is the reason behind potential energy of that water. अगर वही पानी would have been lying on the floor, it might have no energy. क्योंकि there is no potential to fall down. So potential energy is nothing but energy possessed by an object due to its position or its state. So potential energy is given by formula, which is mgh, where m stands for the mass, g stands for acceleration due to gravity, and the h stands for the height from the ground. So that is potential energy for you. Unit is joule and erg, just like जैसे energy का unit था, same would be the unit for potential energy. Okay, so moving forward to the second two types in which potential energy can exist. Now imagine I'm holding a ball at certain height. That ball will have potential energy because of its position. But for a moment, let's imagine that Earth loses its gravity. अगर Earth में gravity ही अलग खत्म हो जाती है, for example, just a hypothetical situation, will that ball in my hand still have that potential energy to fall down? Answer is no, definitely not. So can I say उस ball में potential energy थी because of the gravitational force? So इस type की potential energy को हम बुलाते हैं gravitational potential energy. Now there is one more type or one more form in which potential energy can exist. For example, if I have a bow and an arrow, मैं bow and arrow, मैं arrow को string में अटका के खींच के रख रहा हूँ, it's in my hand yet, so उस arrow में potential energy आ गई. Now, does it have any relation with the gravitation force? No. Can I say the moment I'll release the arrow, it is going to shoot forward? So it has the potential energy to shoot forward. But who is responsible for this potential energy to exist? Can I say the elasticity of the string, right? So that's the second form, which is elastic potential energy, which exists in all the elastic bodies. So these are the two forms in which potential energy exists. Okay, two reasons behind potential energy. Now, the second type of or second form of mechanical energy is the kinetic energy. So the word kinetic refers to motion. So whenever a body is moving, that body possesses kinetic energy. So kinetic energy is the energy of a body due to its motion. The formula for kinetic energy is half mv square, half into mass into velocity square, unit are again joule and erg. So these are the two forms which are very important part of this chapter, potential energy and kinetic energy. Now, sometimes a question is asked कि how did we derive the expression for kinetic energy? जो हमने अभी देखा half mv square, how did we get that? So there's a proof for it. So here we go. We begin with work done का formula. Work done is force into displacement. Now if I have to find force, formula for force, F is equals to mass into acceleration. Now displacement ढूंढने के लिए let us use second kinematical equation. क्या कहता है न्यूटन का second equation of motion? S is equals to ut plus half ad square. So ये है second equation of motion. Assuming कि body starts from rest, okay? अगर body rest से शुरुआत कर रहा है अपने motion का, can I say initial velocity over here यानी u की value 0 हो जाएगी, correct? Let's assume u is 0. So the modified version of this equation would be s is equals to half at square. Now I got my value for force, I got my equation for displacement. अब इन दोनों को सबसे टॉप वाले इक्वेशन में सब्स्टिट्यूट करते हैं. So what do we get for work? So work done becomes force के बदले ma आ गया and displacement के बदले half at square. I hope you're on the same page with me. So half ad square. Now simplifying this, a into a becomes a square and t square already there. We can rewrite it as half m at the whole square. Pardon that 2 over there. So now using first equation of motion, I don't want at square in my equation. So using first equation of motion which says that v is equals to u plus at. ये पहला इक्वेशन है. Now just like previous case, हम u की value 0 consider कर रहे हैं because assuming that it starts from rest. So v is equals to u plus at will become v is equals to 0 plus at. इसको हम रिप्लेस कर सकते हैं v is equals to at के साथ. If I square both the sides, can I say v square will be at the whole square? Now if you observe in the work done का equation here, work done में at the whole square है which can be replaced by v square. So what do we get here? Half m v square. Now work done is always equal to energy, and in this case we say work done is equal to kinetic energy. So kinetic energy is equal to half m v square. Okay, so that's how we get the formula or equation or expression for kinetic energy. So moving forward, there's a very important principle और लॉ आई कैन से लॉ ऑफ कंजर्वेशन ऑफ एनर्जी। इसका स्टेटमेंट भी काफी इंपॉर्टेंट है और एप्लीकेशन भी काफी इंपॉर्टेंट है। सो व्हाट डज इट से? एनर्जी कैन नाइदर बी क्रिएटेड नॉर बी डिस्ट्रॉयड, इट कैन ओनली बी चेंज्ड फ्रॉम वन फॉर्म टू अनदर। आप एनर्जी क्रिएट नहीं कर सकते हो, ना ही किसी एनर्जी को डिस्ट्रॉय कर सकते हो, बट एनर्जी को आप एक फॉर्म से दूसरे फॉर्म में कन्वर्ट ट्रांसफर कर सकते हो। सो अगर आपकी एनर्जी कभी खत्म नहीं हो रही, नई एनर्जी कभी बन नहीं रही है, देन टोटल एनर्जी इन दिस यूनिवर्स will always remain constant, right? So that is principle of conservation of energy. सो अकॉर्डिंग टू दिस प्रिंसिपल, अगर इमेजिन करो बॉडी के पास दो ही फॉर्म में एनर्जी एग्जिस्ट करती है, मैकेनिकल, देन काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी। सो टोटल एनर्जी विल ऑलवेज बी इक्वल टू काइनेटिक प्लस पोटेंशियल। कभी काइनेटिक बढ़ सकता है, कभी कम हो सकता है, सेम वे विद पोटेंशियल, बट देयर टोटल विल ऑलवेज रिमेन कांस्टेंट, यानी सेम रहेंगे ये। So that is principle of conservation of energy. So as you can see here, energy is interconverted. For example, if you talk about a fan, तो फैन को आप इलेक्ट्रिसिटी प्रोवाइड करते हो और फैन उसको कन्वर्ट करता है बाय रोटेशन इनटू मैकेनिकल एनर्जी। जनरेटर ऑन दी अदर हैंड इज द वेरी अपोजिट ऑफ फैन। वो मैकेनिकल एनर्जी आप सप्लाई करते हो, इट गिव्स यू इलेक्ट्रिक एनर्जी। सेम वे इफ यू टॉक अबाउट लाइट एंड इलेक्ट्रिसिटी, देन सोलर सेल्स यानी फोटोवोल्टाइक सेल्स, उसके ऊपर सनलाइट गिरती है एंड इट गिव्स यू इलेक्ट्रिसिटी। वेरेज इफ यू टॉक अबाउट अ बल्ब और अ लैम्प, उसको आप इलेक्ट्रिसिटी प्रोवाइड करते हो एंड ये इट गिव्स यू लाइट एनर्जी। So they are vice versa of each other. उसके बाद if we talk about chemical energy, so if you charge your mobile phone, electricity is getting converted into chemical energy of your battery or a cell. और वही फोन को अगर आप यूज करते हो, then the process is other way around. Then comes sound energy. Sound का एक बेस्ट एग्जाम्पल इज माइक। माइक को यू प्रोवाइड साउंड एंड माइक कन्वर्ट्स इनटू इलेक्ट्रिक सिग्नल्स, जबकि लाउड स्पीकर में सिग्नल्स आते हैं और इट कम्स आउट इन द फॉर्म ऑफ साउंड। If you talk about electricity and heat energy, so heater is a device which takes in electricity and gives us heat in return. Whereas thermocouple, which is used in your ACs and in your refrigerators, it controls the amount of electricity depending on the temperature. यानी heat लेता है and electricity provide करता है. So that's how things can be interconvertible. So ऐसे बहुत सारे examples है textbook के which needs to be considered and remembered for each and every conversion of energy. Now, there's an important theorem in this chapter, which is work energy theorem. So here we have to prove that work done by any body is equal to change in kinetic energy of that body. So how do we prove that? Let's begin. To begin with, work done ka formula. Work done is force into displacement. Now, force as usual is mass into acceleration. By third kinematical equation, we say V square is U square plus 2AS. Now, assuming we have to find out displacement here, so S will become V square minus U square upon 2A. तो ये दोनों ही चीज को अगर हम मेन इक्वेशन में यानी फर्स्ट इक्वेशन में सब्स्टिट्यूट करते हैं, तो व्हाट डू वी गेट? वी गेट वर्क डन इज फोर्स के बदले ma आ गया यहाँ पर, एंड डिस्प्लेसमेंट के बदले v square minus u square upon 2a. So over here a and a gets cancelled. So what are we left with? We are left with half m v square minus u square. Now if you open this bracket, half m goes to v square as well as u square. तो दोनों के पास we have to multiply it. So what is left here is half m v square minus half m u square. Now if you observe carefully, half mv square is the formula for final kinetic energy and half mu square is the formula for initial kinetic energy. So final minus initial आप जब भी कर रहे हो, what are you indirectly finding is change. So can I say from this statement that work done is equal to change in kinetic energy? So there you go. Hence proved work energy theorem. काफी important part है ये. Okay. Now there's another derivation which is for a law of conservation of energy when a body is in free fall. अब ये derivation काफी लंबा है. So many of you think that it is very difficult or tricky and they don't actually study this. But in reality, that's not the case. अगर आप ध्यान से देखोगे, step by step follow करोगे इसको, so it's pretty easy and pretty cool. It's just that repetition of steps happens for all the cases here. So let's get started with, imagine a ball which is held at a height h from the ground. Ball is in our hand, so initial velocity is taken as 0. The ball will be falling down anytime soon. So when the ball falls, let's consider three different positions of this ball. A being the topmost position, B being any random position in between, and C is when it just touches the ground. So when it's falling down, acceleration of this ball happens because of gravity. So acceleration due to gravity is denoted by letter G. Let's say the total height is h. A और B के बीच का जो डिफरेंस है उसको हम लेते हैं x. So बचा हुआ पार्ट B to C becomes h minus x. Now, in this entire derivation, याद रखना ये है कि whenever displacement is asked, you calculate it or you find it from the top. And whenever height is asked, you calculate or determine it from the bottom. Okay, so that's the main trick you need to remember. At point A, B, and C, what is the purpose or what are we trying to prove here? हमें ये ढूंढना है कि point A, point B और point C पे total energy of this ball is always same. Okay, that's our purpose. अब just we have learned कि total energy is nothing but kinetic energy plus potential energy. So in short, आपको इन तीनों points पे kinetic energy ढूंढनी है और इन तीनों points पे potential energy ढूंढनी है और इनको add करके total energy. ठीक है. सो एज यू कैन सी हियर तीनों पॉइंट पे मैंने काइनेटिक एनर्जी का फॉर्मूला यूज कर लिया, हाफ एम वी स्क्वायर. तीनों पॉइंट पे इफ आई अप्लाई पोटेंशियल एनर्जी का फॉर्मूला एम जी एच, एंड तीनों पॉइंट पे वी अप्लाई टोटल एनर्जी का फॉर्मूला विच इज काइनेटिक प्लस पोटेंशियल. दैट्स अ कॉमन ट्रेंड इन ऑल थ्री पॉइंट्स. नाउ लेट्स फिल इन द गैप्स हियर. ठीक है. सो पॉइंट ए की बात करें, पॉइंट ए पे क्या क्या स्पेशल चीज है. पॉइंट ए पे वेलोसिटी यानी इनिशियल वेलोसिटी इज इक्वल टू 0. ओके, तो काइनेटिक एनर्जी विल बी हाफ एम वी स्क्वायर. तो v के बदले हम 0 पुट कर रहे हैं, तो एंटायर काइनेटिक एनर्जी बिकम्स 0. सो दैट्स फॉर पॉइंट ए. अगर ए का पोटेंशियल एनर्जी ढूंढते हैं विच इज एम जी एच, हाइट ऑफ पॉइंट ए, एज आई टोल्ड यू बिफोर, हाइट देखना है आपको नीचे से. So from the ground, point A का difference is h, so height is h over here, remains h, no changes. So potential energy becomes mgh. अगर आप इन दोनों को add करते हो तो 0 plus mgh will give you answer mgh. That's my total energy at point A. अब चलते point B पे. पॉइंट बी और पॉइंट सी में एक छोटा सा कॉम्प्लिकेशन है. ए पे इट वाज वेरी इजी टू फाइंड बिकॉज वी न्यू द वेलोसिटी एट पॉइंट ए, बट वी डोंट नो व्हाट वुड बी द वेलोसिटी एट पॉइंट बी और व्हेन इट रीचेस द ग्राउंड एट पॉइंट सी. ये हमें नहीं पता. सो वी आर इन एन अनसर्टेनिटी. सो व्हाट विल वी डू? विल ट्राई टू फाइंड आउट velocity at point B and point C using third kinematical equation. So as you can see, similar pattern for point B and point C. The third kinematical equation says that v square is u square plus 2as. दोनों जगह पे अप्लाई किया. Now point B का s यानी displacement from the top. Please remember this. From the top, if you observe, B के लिए displacement is this length which is x, and C के लिए displacement is the total height h. So substituting these values, okay, acceleration is g throughout the motion and displacement is x, so ये बन गया 2gx and velocity initially was 0. So v square हमें मिल गया 2gx. क्या फायदा होगा? Let's go for kinetic energy now. Kinetic energy half mv square. Can you see v square के बदले हमने substitute कर दिया 2gx. So 2 gets cancelled here and what's left with mgx. अब पोटेंशियल एनर्जी ढूंढना उतना ही आसान हो गया है. पॉइंट बी के लिए हाइट mgh में हाइट इज फ्रॉम द बॉटम h माइनस x. सो हाइट के बदले वी सब्स्टिट्यूट h माइनस x. So when we open the brackets here, we get mgh minus mgx. So total energy में सब कुछ substitute कर दिया, तो what are we left with? Can you see mgx and minus mgx will get cancelled? So we are left with only mgh. So point A और point B दोनों पे हमें total energy मिल चुका है mgh. Now we talk about point C. C का displacement from point A, C का displacement is nothing but total height h. So ये v square will become 2gh over here. अब यही v square को kinetic energy ढूंढने में हम यूज कर लेंगे. So what will we get? Half m into 2gh. 2 gets cancelled here. So if we cancel 2 and 2, what are we left with? mgh. Alright. So now हम ढूंढते हैं C का potential energy with the flow. mgh height चाहिए आपको. Point C का height from the ground. Can I say C is itself on the ground? So height will be 0. So what are we getting the potential energy as? 0. Okay. So total energy will be kinetic plus potential, which is mgh plus 0 is equals to mgh. So tada, there we go. तीनों की total energy आपको mgh आई. Hence in the end we can say law of conservation of energy is proved. Okay, at every point we are getting the same total energy, which is mgh. So there goes your derivation. Then we have an example of simple pendulum, how potential energy and kinetic energy changes when it is swinging. So you will observe here, when it's at the extreme positions, it has maximum potential energy and zero kinetic energy. Whereas when it's at the mean position, yani at the bottommost position, it has zero potential energy and maximum kinetic energy. That's how conversion of energy takes place in a swinging pendulum. So potential energy always converts into kinetic energy. So that's the conversion that you will see in all the cases. Now, to begin with, numericals. As I said, numericals are the major part of this chapter and likely asked question. So we have distributed numericals into different types, and depending on the type, we have a special formula for each type. So type 1 is based on work calculation, which is Fs cos theta. So please remember this one thing कि cos theta आपको सिर्फ तब यूज करना है when there is a angle difference between force and displacement. जब तक force और displacement के बीच में कोई भी angle difference नहीं हो, then the work done remains F into S. So let's begin. Very first question. A boy when acted upon by a force of 10 kgf, तो ये आपको force दिया है 10 kgf, gets displaced by 0.5 meter, तो ये उसका movement दिया है. Calculate the work done by the force when displacement is in the direction of force, 60° with force and normal to the force. So over here, this is the best example for using all different formulas. where we have three variations between force and displacement. So let's use diagram to understand the three cases. सबसे पहला केस, फोर्स एंड डिस्प्लेसमेंट आर इन द डायरेक्शन, यानी सेम डायरेक्शन में है. सेकेंड केस, फोर्स एंड डिस्प्लेसमेंट आर एट एन एंगल 60 डिग्री विथ ईच अदर. लेट्स अज्यूम ये दोनों के बीच का एंगल 60 डिग्री है. एंड द थर्ड केस वेयर दे आर परपेंडिकुलर, यानी नॉर्मल टू ईच अदर. So, line by line, we will solve three cases here. पहले let's see what all things are given to us. तो पहले हमें force दिया है, but only problem is it's in kgf. So kgf को न्यूटन में convert करना है, so multiply by 10. So 100 Newton is the force. Displacement की value for all three cases is same, 0.5 meter. And we start with the case 1. So this is the common formula. केस वन, क्योंकि दोनों सेम डायरेक्शन में है, देयर इज नो थीटा ओवर हियर, सो 0 डिग्री. सो एफ इंटू एस, फोर्स डिस्प्लेसमेंट मल्टीप्लाइड 100 इंटू 0.5, 50 जूल. अब देखते हैं सेकेंड केस में. वर्क डन इज फोर्स इंटू डिस्प्लेसमेंट इन द डायरेक्शन ऑफ फोर्स, सो एफ एस कॉस थीटा आया. सो हियर एंगल बिटवीन देम इज 60 डिग्री, सो cos 60 will be a factor in the formula. So when we multiply, cos 60 is 0.5, yani half. So here 100 into 0.5 into 0.5, which gives me 25 joule. Second answer. Moving to the third case where they are normal, yani perpendicular to each other. Best one, since they are at 90 degree to each other. In this formula, W is F into S into cos theta. Cos 90 becomes 0 and everything becomes 0 over here. So that's how you use Fs cos theta for different variation. All right. So moving to second type, which is power calculation. Power is work upon time. Work can be replaced by energy, so energy upon time. So that's for power calculation. Let's have a look at first example. A weightlifter lifts a load of 200 kgf. So imagine this weightlifter having a dumbbell of 200 kgf and he lifts it till a height of 2.5 meter in 5 seconds. We have to find out the work done by him and the power developed by him. Okay, value of G we have to take 10 instead of 9.8. So that's given, so we can use it. Good for us. So to begin with, what all things are given? We have force again in kgf. Don't forget to convert in Newton every time. So 2000 Newton it becomes. Displacement is nothing but height, which is 2.5 meter, and time given is 5 seconds. So how do we begin? सबसे पहले work ढूंढेंगे. Since both are in the same direction, there is no complication of cos theta here. So what will we get? Work done is F into S. Force into displacement, 2000 into 2.5, 5000 joules. Now second part, which is power, work upon time. बड़ा ही simple straightforward form numerical है ये. So work done divided by time and we get 1000 watts. So that's for power calculation, guys. Question 8, a quick go through. Electric heater who has power 3 kilowatt. So power taken as 3 kilowatt. Time given is 10 hours. How much energy does it consume? So since we know power is energy upon time, energy will become power multiplied by time. So since here we are already provided with power 3 kilowatt, we are already provided with time 10 hours. So 3 kilowatt into 10 hours becomes 30 kilowatt hour. But यहाँ पे variation ये है कि you have to express them in two different units. So kilowatt hour first unit, done and dusted. But second one is joule. So please remember this conversion. काफी sums में ऐसा variation आता है that they ask you specifically in kWh or in joule. So if we go by joule here, 1 kilowatt hour is 3.6 into 10 raised to 6 joules. If you remember, हमने जब पावर के बारे में यूनिट्स के बारे में इलेबोरेट किया था, तब 1 किलोवाट आवर इज 3.6 into 10 raised to 6 joules ये डिफाइन किया है. So अगर 1 kilowatt hour is this much, 30 kilowatt hour will be 30 into the same number. Therefore, we get 1.08 into 10 raised to 8 joules. So that's again a power calculation sum. Let's have one more example where a water pump raises the 50 liters of water by a height of 2.5 meter in 5 seconds. Calculate the power which the pump supplies. So यहाँ पे थोड़ा सा complication है, और वो ये है कि unlike other questions, you are not provided with force over here. Okay, so force नहीं दिया, displacement is given in the form of a height 25 meter, time is given. So how do we find the force is the twisted part in the sum. So instead of force, what are we given? We are given with 50 liters of water. We are also provided with density of water. So mass is given, density is given. So how are we going to use it? Check this out. So first thing, sorry, my bad, volume is given and density is given. So first thing we can use this 50 liter को meter cube में convert करते हैं. So in order to do that, multiply by 10 raised to minus 3. So that is volume in meter cube. After that, density is given. So density and volume will help us find out mass. So mass will be volume into density. Density was mass upon volume. So दोनों को multiply करते हैं, we get our mass which is 50 kg. चलो mass मिल गया, हमारे पास G है, तो M into G will be our force. So we now have all the things needed to find out force. Force है आपके पास, displacement है, things are pretty clear now. So let's begin with work done. Work done is our force into displacement, which is mg into h, which becomes mgh. इस वर्क को पावर ढूंढने में यूज करेंगे हम. So power will become work upon time, mgh upon t, which is nothing but 50 into 10 into 25 from the given part upon time taken is 5 seconds, and what comes out to be 2500 watts. So there goes our power. So ये सम इसलिए सिलेक्ट किया क्योंकि यहाँ पे something new to find out work is given to us. Now coming to type 3, हमने work देखा, हमने power देखा. Now let's have a look at energy calculations. So energy में two different types are asked. Kinetic energy, which is half mv square. Other formula for the same is p square upon 2m, where p stands for momentum. So momentum, mass into velocity. Then we have potential energy, which is mgh. So ये दोनों चीजें आपको help करेगी finding out different kinds of energy calculation. Let's have a look. Assuming a car, F1 car, which is having a mass of 624 kg, moving with a speed of 150 km per hour. 150 km per hour. Kilometer per hour is a red flag. Don't forget to convert into meter per second, which is a standard unit. तो अगर हम बात करते हैं, आपके पास मास दिया है, आपके पास स्पीड है यानी वेलोसिटी है, और काइनेटिक एनर्जी ढूंढने बोला है. सो वी हैव वेलोसिटी, वी हैव मास. सो फर्स्ट ऑफ ऑल ये रेड फ्लैग को सॉल्व करते हैं कि आपको मास दिया है, वेलोसिटी दिया है. तो किलोमीटर पर आवर वी नीड टू कन्वर्ट इनटू मीटर पर सेकेंड. सो either multiply by 1000 upon 3600. Kilometer to meter is 1000, and denominator में r to second is 60 into 60. Or you can directly have a shortcut 50. Sorry, here you can directly convert into 5 by 18, which is the same thing to convert from kilometer per hour into meter per second. अब आपके पास मास है, वेलोसिटी है, बहुत ही सिंपल है इसको फाइंड करना, हाफ एम वी स्क्वायर से हाफ इंटू मास इंटू वेलोसिटी का स्क्वायर विच गिव्स यू 571,453.34 जूल. So that's kinetic energy calculation. Look at potential energy का sum. Vessel containing 50 kg of water. So mass दे दिया 50 kg. Placed at a height of 15 meter above the ground. So H दे दिया. Assuming gravitational potential energy of the ground to be zero. मतलब ground is our point of reference. What will be gravitational potential energy? So mgh, even in the question they have mentioned take g का value as 10, वरना आपको 9.8 लेना है if not mentioned here. So m into g into h, 50 into 10 into 15 gives me 7500 joules. That's question 7 for you. I mean for potential energy calculation. Now एक और एग्जाम्पल लेते हैं इसका. बॉडी ऑफ मास 60 kg, मोमेंटम. मैंने कहा था कुछ ऐसे सम्स हैं जो मोमेंटम बेस्ड होंगे पी के रिलेटेड. सो उसके लिए काइनेटिक एनर्जी का सेकेंड वेरिएशन का फॉर्मूला में यूज करना है. सो मोमेंटम 3000 kg मीटर पर सेकेंड है. काइनेटिक एनर्जी एंड स्पीड, ये दो चीजें आपको ढूंढनी है. सो हाउ डू वी गो अबाउट इट? लेट्स राइट डाउन मास 60 kg, पी 3000 kg. तो अगर आपके पास p है, m है, तो यूजिंग फॉर्मूला फॉर मोमेंटम वी कैन फाइंड आउट वेलोसिटी. तो सबसे एंड काइनेटिक एनर्जी के लिए p स्क्वायर अपॉन 2m विच इज द सेकेंड वेरिएशन ऑफ फॉर्मूला फॉर काइनेटिक एनर्जी. सो सबसे पहले काइनेटिक एनर्जी ढूंढते हैं. p स्क्वायर 3000 स्क्वायर अपॉन 2 इंटू 60, 3000 square upon 2 into 60, which gives me 75,000 joules. Now second thing which is given as momentum, p is m into v. आपके पास p है, आपके पास mass है, so velocity ढूंढने के लिए इन दोनों को डिवाइड कर देंगे. तो 3000 upon 60 gives me 50 meter per second. So that, ladies and gentlemen, is how do we use the variant of kinetic energy का formula. Moving to the fourth type, जो law of conservation of energy पे based numericals है. So total energy is kinetic plus potential. That's the formula for law of conservation of energy. So इसमें काफी application based questions आते हैं. So let's have a look at one. So sorry, that came first. Okay, so question says a stone of mass 500 grams is thrown vertically upward. So you're throwing a stone upwards with a speed 15 meter per second. We have to calculate potential energy at the greatest height, kinetic energy on reaching the ground, and total energy. It is halfway point, यानी mid point पे. So if we go by this, सबसे पहले potential energy at the greatest height. Can I say आपके पास given है mass and velocity और पूछ रहे हैं potential energy at greatest height, तो आपके पास height की requirement होगी. So if we go by the normal approach, you will be confused how to find out potential energy without height. But if we have a wide approach, can you see potential energy at the top will be equal to kinetic energy at the bottom, क्योंकि energy खत्म नहीं होती, converts from one form to another. So using that application, that logic, जो भी kinetic energy ground पे होगी, same potential energy top पे होगी. So that logic can be helped here. So by law of conservation of energy, potential energy at the top will be equal to initial kinetic energy at the bottom. So क्योंकि आपके पास mass और velocity है, it will become very easy to find out potential energy. So check this out, half mv square, which gives me 56.25 joule. अब second question पूछा है kinetic energy on reaching the ground. Simple है, जो आपने अभी ढूंढा सेम वही वैल्यू होगी ऑन रीचिंग द ग्राउंड, जो पोटेंशियल एनर्जी टॉप पे होगी. सो आंसर वुड बी सेम. एंड Midway can I say jitna half kinetic energy convert hoga into half potential energy. So it will be half of kinetic and half of potential. Dono ka addition, which gives me again the same thing, 56.25 joule. So that's some based on law of conservation of energy, and that overall completes your entire chapter with numericals based on all different variations. So I hope this entire revision lecture would be beneficial for you. You can use it even during your board exams or even during your test for a quick revision of this entire chapter within, let's say, 1 hour. And this sessions will be staying here on our YouTube channel for a long period of time. So don't hesitate to like, share, comment, and subscribe to our channel on Arihant Academy. I'll see you some other day with a new chapter, with a new topic. Till then, everyone, take care. Bye bye. Stay safe.